Hello, in this video we are going to evaluate a definite integral. Evaluate the following definite integral. Integral from 1 to square root of 3 x to the 2x squared plus 1 plus ln of x to the 2x squared plus 1 dx. On the next slide I will give you a hint how to solve the problem. If you don't want to see the hint, pause the video at this point and give it a try yourself. As a hint, I can give you the following instruction. You can call the integral I and introduce a new variable, capital X, as follows. Capital X equals to x squared. Pause the video at this point and give it a try again if you couldn't solve the problem yet. On the next slide, I will show you the final answer. So if you don't want to see the final answer, pause the video at this point. The final answer to the problem is 13. Okay, so according to the hint in the problem, I would say that x squared is equal to capital X. Then of course differentiating both sides will give me 2 little x dx equals to d of capital X. And then from here, what I will do, I will keep it for the time being like this. And then I start finding the limits of the integral in terms of the new variable. So little x goes from 1 up to square root of 3. So this would imply that capital X goes from 1 to 3. Yes, so I replace little x with 1. 1 to power 2 is 1. And then I replace little x with the square root of 3. So square root of 3 to power 2 is 3. So these are the limits of the integral and expressed in terms of the new variable capital X. Okay, but now I try to write this expression as much as I can in terms of capital X. So x to the power of 2x squared plus 1 can be written as x to the power of 2 to the power of x squared multiplied by an extra x. Okay? For the time being, I keep this little x, but instead of this x squared and this x squared, I can put capital X. So if you don't mind, let me write the little x on the left, and then I will have capital X to power capital X. Okay, the second part, the argument within the ln, can also be written similarly. Okay, so I will try to write this in terms of capital X as much as I can. So let me start there. So I have x to the power of 2, x to the power of 2x squared plus 1. Yes, so if you see here, this part of the problem is exactly this expression that appears here, and I can write it in this form. Okay, so then it becomes x squared, yes, to the power of x times x to the power of x. But then this x squared can also be written as capital X. So this becomes capital X to the power of little x times capital X to the power of capital X. Okay, but now I want to calculate this ln of the expression there. So ln of x to the power of 2x to the power of 2x squared plus 1 now can be written as ln of capital X to the power of x times x to the power of x. But now, because of the property of ln, I can put this to the back of the ln. So that expression becomes equal to little x times capital X to power capital X ln of capital X. Okay, so the integral that I call it I now can be written as integral from 1 to up to square root of 3 now can be written as 1 to 3. And then instead of this expression, I can write this. So this becomes little x times capital X to the power of capital X plus. instead of this expression, I can write this. So this becomes little x times capital X to power x and ln of capital X, and then everything multiplied by d of little x. But d of little x now can be calculated here. So d of little x is equal to d of capital X divided by 2 divided by little x. So I would write it here. So this becomes d capital X divided by 2 little x. Okay, so now what happens? This 1 over 2 goes to the back of the integral, because that's a constant, integral from 1 to 3. And from here, this expression is in common. I can factor it out. So this becomes x times capital X to power x, and then what is left for me is just 1 plus ln of capital X multiplied by d of capital X divided by little x, because that factor of 2 is pulled out from the integral. And now the last remaining of the old variable now is gone. And now I would say that this change of variable is successful, because now my integral is written only in terms of my new variable, capital X. But hopefully this expression should look familiar to your eyes. Yes? This is the derivative of this function with respect to capital X. Why is that? And that is the logarithmic differentiation. So for example here, I would say that let introduce a new variable. I would introduce a new variable u as x to the power of x. And I want to calculate the derivative of this function. So in order to do that, hopefully you remember from your calculus course that you just take ln from both sides. Then the right hand side becomes x ln of x. And then you differentiate both with respect to capital X. The left hand side becomes u prime over u by the chain rule, and the right hand side is the product rule, the derivative of capital X times ln of x, which becomes this, plus the derivative of ln of x, which is 1 over x multiplied by x, which is just simply 1. And then if I ask you what is u prime is u is this expression multiplied by u, but u is this expression itself. So u prime becomes x to power x 1 plus ln of x. So this means that if I take this expression to be u, this expression is nothing except du. So I will write this integral in terms of u now. So this becomes 1/2 integral, and then I will have du. But the limit will also change, yes? Here I would say that capital X goes from 1 to 3, which implies that little u goes from, instead of capital X, I put 1, so the answer becomes 1. And instead of capital X, I put 3, so the answer becomes 27. So this becomes 1 over 2 integral from 1 to 27 du, and that is just 1 over 2, 27 minus 1, which is 26. So the answer becomes 13, and this will be the answer to this integral. Okay, I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.